Thanks, everyone. Great to be here. Very excited to be back here at the Want2Be conference. So I want to talk to you about the future of trust in LLMs. And one thing that is helpful to start is to take a look back. This has been a journey for me for almost a decade at this point, where I have worked in what we called NLP, machine learning, AI research. Now we could say maybe these are all steps towards AGI. But I've been very excited since about 2010 to have a single, what I was excited about, pre-trained model. This idea that we can transfer knowledge from many different tasks to other tasks in the future, just multitask learning. And in my thesis, I already tried to have both models that would understand natural language as well as images, as one of the authors of ImageNet. But this whole idea culminated in 2018. And it's sort of a personal anecdote that I hope will motivate some of you to also continue working on some really hard problems that are not yet obvious. I feel like there's so much energy now in the field of AI. There are a lot of low-hanging obvious fruit. But oftentimes, when you're a little bit ahead of the curve, it's not yet obvious to others. And so this was the paper that I thought was the culmination of almost a decade of research. We called it the Natural Language Decathlon. Basically, multitask learning as question answering. Now we call these questions prompts. But really, before this paper, basically every NLP, state-of-the-art NLP system would train one model for one task, right? You have a sentiment analysis task on Twitter, you train one model for that. You want to do machine translation, you train a model for that. You want to do summarization, you train a different model for that. And I had pre-trained word vectors before. I had pre-trained sentence encoders, contextual vectors before that became Elmo and then BERT later. And I wanted to pre-train also the decoder, the part that actually gives you the output. And the only way to do that was to try to squeeze every task description also into the inputs of the model. And so the idea of this model and overall structure was to cast all these tasks as question answering over some context. So I'd give you a context, here's a tweet, and I ask, what is the sentiment of that tweet? What is the summary of this paragraph, and so on. So now, after the culmination of all this decade of research, we actually published this paper, and it was very public on ICLR. ICLR is this very great conference, and unfortunately, the paper got completely rejected, and the area chair was absolutely certain that it makes no sense to try to squeeze all the tasks in NLP into a single model. And all the reviewers were like, this is misguided, overcrowded. They said there's no such thing as general question answering, not even for humans. And I'm like, have you ever heard of this thing called the brain? Do you really switch it around every time you ask a different question and you don't use the same kind of brain? And I mean, even humans, it's like, it was absurd. Anyway, it was a huge bummer. Very, very, now it's kind of funny, but at the time, it was like, man, the first author, Brian McCann, he had worked on this also for over a year just to do all this pre-processing, right? Because all these different communities in NLP, the summarization community thought of don't as do space and apostrophe T, and other, in sentiment analysis, people thought of it differently, and just what is a word was there are all these different pre-processing steps, and that just took several months to get all these different academic benchmark data sets together, and then obviously training the model and trying all these different iterations. And that's actually also, we started to using weights and biases back then at Salesforce Research, and there's a whole team, and we worked on it for so long, and it was a huge bummer. Fortunately though, the paper did get cited by a few different research groups and inspired a couple folks, including the likes of Alec Radford and Ilya Sutskever, who basically said, look, they showed that a language can provide a flexible way to specify these different tasks and inputs and outputs, all as just sequences of symbols. And the rest is sort of well-known history. This is a GPT-2 paper. And after that, it sort of became more and more obvious that you can have a single model for all of NLP. And I'm really, really excited to see this. And then basically at that point, in the late 2010s, research-wise, I thought, well, we're going to do a lot of cool stuff with that, right? But then a year went by, and I felt like if I have a single model for all of NLP, and I can ask it all these different questions, why am I still in a search engine getting a list of blue links for the most part with a bunch of ads? And it was very obvious to me that search was kind of the biggest application of all of this research that I've done for over a decade. And you look at research and you see, or at search, and you basically didn't see that much of a difference. I mean, there's a lot more ads now, and there are some widgets here and there, but this high-level idea of like, here's a bunch of links that should give you the answer just didn't seem right. And so that was another kind of rejection sequence coming in, because we said, hey, we think we can build a better search engine, and it's going to be much more about answers and summarization and so on. But a lot of folks, a lot of VCs were also highly, highly skeptical. And this is my second startup, so I thought a lot more people would be like, well, he did it first, earlier, so maybe he'll do it again. But no, a lot of VCs did not like the idea and thought you cannot change the way people search. It's just not possible. And to be honest, even a lot of users were like, we started putting LLMs into the list of blue links. Like, oh, you're looking for some code, here's an LLM that will write that code for you. But even users were often saying, I'm so used to Google, I don't want anything too different. And that all changed when ChatGPT came out. There's a big change in the user perception of how you can actually get answers. And so we already had a bunch of LLMs in search results, so it's very easy for us to say, let's just connect these LLMs to the web, to our search index, and then give highly accurate answers. And we basically did what is now called RAG. We just called it like a web-connected LLM. The RAG term didn't exist yet. And we basically made LLMs be up to date with responses and citations and so on. Unfortunately, though, despite a lot of exciting progress and it being able to answer a lot of new questions that you wouldn't have ever asked Google before, there's still a lot of problems, namely with hallucinations. And so I want to talk a little bit about how we can tackle these hallucinations and be able to trust LLMs more in the future. And there's sort of 3 different challenges that we tackled, and I'll just go through them. The first one, of course, is that you cannot train an LLM every 5 minutes a news article comes out. Right? It's just not possible right now. And so that leads to them being outdated and also not up to date and really trustworthy ultimately. And there are a lot of different examples. Here's one particularly interesting one. You would think OpenAI and Microsoft could build hallucination, sort of less hallucinating kinds of LLMs. But this was a crazy chatbot that came out where Microsoft partnered with the city of New York City. And basically, that chatbot would just tell businesses to break the law, like left and right. You'd be like, yeah, you can totally discriminate poor people for rent assistance and deny them like moving into your apartment. And it was actually pretty crazy, because I read this article and I just put in most of those questions, all those questions that I saw in the article into u.com, and it got them all right. And I'm like, we didn't even get probably millions of dollars from the city of New York to make sure it works correctly. But when you have once a really well-defined search index that is built for LLMs and not for people to choose which link to click, and you combine all of that, you can actually be much, much more accurate. So the first bit was basically trying to have this real-time web access and the citations. And it's really interesting because there have been a lot of copycats with this idea of LLMs with citations. And sometimes we're like, wow, they're even faster than we are. So we did some studies and some benchmarks and put our research hats on. And we actually looked at how often, when there's a link behind a sentence, how often is that fact actually mentioned on the page that that link sends you to. And it's interesting because there's some of our competitors that basically just add random links behind sentences. And then you click on it, and half the time, it's just an hallucination still. It wasn't actually mentioned in that supposed reference. So I'm a little bit worried sometimes. Folks are moving quickly, and it is quick to build a prototype of this kind of stuff, but to actually make it accurate does take a lot longer. So the second one is kind of this misattribution of sources and hallucinations, and wanting to really have a very long, very carefully researched article where you wouldn't just get a citation to this page, but it actually would scroll down and send you exactly which sentence it found that fact in, and it would write you much more careful research reports. And this is something that we've actually observed now a lot of companies being interested in. So we had a bunch of LOIs, and like next month we're actually releasing an API for what we call research mode. So here's an example of Reddit S1 filing that we posted, and I thought it was a little bit facetious because I don't think we've logically will never have hallucinations, but in practice I haven't seen a hallucination in months in this new research mode that will write these very carefully researched reports for you, and will give you literally like 1 or 2 citations for every single sentence that you read in those responses. And so I tweeted this, and then someone did a quick fact check and actually used different models like Gemini and so on to fact check the research report that I posted. And it was really interesting. Google, you would also think, has all the AI, all the capabilities. And then the Google bot, Gemini, actually said that this fact here is wrong. It said in our report, Reddit's user base has been expanding with approximately 52 million daily active users, over 100,000 active communities. Your site, this is wrong. There are so and so many active communities. And then you can actually just click on the citations, and it goes directly to those sentences. And it turns out the fact checking of Google on our research report was actually wrong, and it was actually correct. And so this points to an interesting issue, which is sometimes in generative AI, if you create an artifact, but it takes you longer to verify if it's a good artifact or not, then the usefulness of Gen AI in your startup ideas and other like products and so on goes down, right? Like in images, it's perfect. Like it would take you forever to illustrate a new image, but you can quickly look at it and like, that's perfect. But if you have a very long answer and it takes you forever to verify each fact and you can't trust it because you don't have citations behind every sentence, then it actually at some point loses its usefulness. And so this was a fun one. This was particularly fun because the New York Times reporter said, oh, these guys shouldn't say these things, and then he was also wrong. So, but yeah, in general, what we've seen now is like a much higher requirement to be accurate. And again, here, when you click on these links, it will mark it up. So there's like this blue box is just for the slides, but the red in Chrome browsers, it will actually like scroll down and mark up exactly where it found the fact for that citation in research mode. Research mode is also slower, but it really replaces like hours of work rather than minutes of work in our default free smart mode. This becomes even more important now, and there are a lot of startups now that are starting on just trust for LLMs, because there's this interesting Air Canada chatbot, and in case you haven't heard of this, it's an interesting story. Namely, a chatbot said, yeah, you can get a free coupon for a free flight, but it was just a chatbot hallucinating, hearing on the internet about free coupons, and then Air Canada got sued for it, and Air Canada was like, well, this is just a chatbot, like tell the company, and like it's not our fault, but it was actually ruled that no, Air Canada has to give people that free flight for the coupon. And so that one case freaked out a lot of companies. And now companies, because of that, are moving more into internal chatbot use cases and away from customer-facing ones in many cases. And so, again, it's kind of tricky because we can quickly hack up prototypes and find a few cherry-picked examples where it's like, oh, this is great. But then if you actually want to run this in production and you have to trust it, and money is on the line, and your reputation as a company and so on, the bar all of a sudden gets really, really high. So the last one and biggest challenge, I think, intellectually for these LLMs is what Daniel Kahneman called System 2 level reasoning, like complex mathematical reasoning, logical reasoning, reasoning about physics, and so on. And there's some detractors of LLMs who say, oh, they will never do this. it's the wrong approach. You got to have symbolic reasoning and so on. And I think that actually lacks imagination too. And I do think LLMs have the potential, but it's not the way you would think they would do it. At a high level, it is actually kind of sad that you ask an LLM, like a large model, billions of parameters, like what's 563.57 times some other number, and it will do billions of matrix, like billions of multiplications, essentially, in many, many matrices, and still give you the wrong answer, right, for a simple multiplication problem. There's a little bit of a sad irony to that. At the same time, people figured out that you can have these models write code, and then they just translate that code. And then if you allow the AI to execute that code, then boom, all of a sudden that entire set of problems is solved. So here's a really cool example from an actual user who just told us, like, no way, they got this entire thing correct. So it's a math problem. There's a Ferris wheel, diameter of 60 meters. You can do it in your head a little bit. It's not that hard, at least to get the idea roughly of what this should look like. And then you translate all of that into code, and then eventually it will actually run that code and then give you the answer, which is pretty incredible that it does that. And what that means is also that you now can solve basically math problems, physics problems, chemistry problems, and problems that require logical reasoning better and better with these models. And it's this whole nother set of hallucinations that can be resolved. And maybe as a last point here, at U.com, we actually struggle a little bit, and I'm sure some of you struggle. You built a model, you built a whole product around one model, and now there's a new model coming out, right? And that happens every week. Today, Llama 3 came out, right? And now you've fine-tuned your previous model, and it's kind of stressful. And honestly, I was personally also stressed out because we're like, we have to, at some point, basically make our entire LLM orchestration layer independent of the most important component, which is the central LLM. And for a while, we were fighting it, and now we kind of embraced it. And now we just say, all right, as soon as a new model comes out, a day or two later, sometimes on the same day, like with the Databricks Instruct model, DBRX, we just enable it and let users play around with it. And it usually takes a couple of more days or sometimes even weeks to really use the power of these models, like file uploading with each of these different models and so on. There's often more work that needs to be done. But at this point, when you use U.com, you can basically use any of these models very, very quickly. And it's super fascinating to see sort of models spiking, and a lot of people get excited about one model, and then it falls away and goes back to different kinds of models. Now, there's one interesting bit, which is some of these models now have context lengths that are very, very long. But when you know that the token price is still a reality, some people are saying, oh, I can't upload this 1,000-page book and then ask 10 questions about it. And I asked my team, like, hey, can we just do it? And they're like, it sounds cool, but it literally will cost about $10 for these 5 questions. And we're charging people $20 a month. And then one user could just rake up thousands of dollars of cost if they keep uploading these massive PDFs. And at some point, we have to say, all right, what does the competition do? They have 5, 10, 30,000, so we'll give 64,000 tokens, but you can't basically enable all of these things. And I think this is kind of, as the LLM field matures, people will have to start looking at cost to serve for some of these models. And I think 64,000 is still such that some power users will probably spend way more than they pay, but you hope that there's a distribution that everyone has to upload 100-page or 1,000-page PDFs every day, and it should be okay. But it is a very exciting time. Now, the biggest bit of hallucinations and trust in LLMs is to essentially evaluate how well these models work. And while there's a lot of useful things, especially as you develop them, that Weights and Biases works on, I think at some point you have a full product and a system, and you just have to compare the full system. And the best way to do that is to just ask users. But it is also not always good to ask users yourself, because you have a certain bias when you ask them. So we actually did a very large benchmarking study where we paid a company called Invisible. Shout out, don't get paid for them, we paid them. But they basically run the study and asked users for a real set of queries that we got. So you don't want to create a bunch of fake queries, because for us it's easy to beat GPT-4 and ChatGPT like 100% of the time by just asking a news-related question. And then they don't have news, there's no really fast web connection, ChatGPT, and then we win the whole thing. So we wanted to take a representative sample of a lot of different user questions, and then we sent it to different competitors, mostly like ChatGPT, but also Perplexity. And to be honest, I thought hopefully we'd do well, but probably we're going to see a bunch of errors, and then we'll have to fix those errors, and then maybe run another study, and then maybe later this year we can like talk about it and then say, oh, look, we're doing really well. Somewhat to my surprise, we are already better than even ChatGPT-4 in user preference. Not by that much, and certainly only because of these two premium modes, which we call the research mode. I showed you of these long reports, as well as Genius mode that will program for you. And it was kind of surprising, and so let me like kind of double click into where this comes from, what we actually did. And so there are basically multiple different criteria. The first one and the biggest one is just overall user preference. Like, do you prefer this answer over this other answer? But then we felt like, well, if we really want to debug this and actually understand why people might prefer one over the other, we have to ask them also to rate all of these different criteria, namely clarity, does the response is actually precise, uses good structure, and also formatting. Formatting, surprisingly important, right? If you just have a bunch of blobs of text versus like nice paragraphs with bolded titles and so on, it's a big difference. Comprehensiveness, conciseness, those two often battle each other out. It's hard to be super comprehensive, but also extremely concise. The biggest one, factuality or accuracy, is what we call it. That to me is the most important one. And sometimes people argue, I think correctly, that you want hallucinations in some use cases, right? And sometimes it's hard to know. Like if I want to write about how aliens invaded Berlin in 2040, because I want to write a new short story or novel about it, I want the model to hallucinate, right? But then if you ask that how that happened in 2010, because you think all people are like lizard people and there's like a big conspiracy theory going on, then you don't want it to hallucinate, right? And this is hard to know. But for a search engine, the default should be we are factually accurate. We're not hallucinating. And so factuality and accuracy is super important. And then faithfulness is another interesting one that we didn't think of right away. But it's basically if I say, hey, I'm a father, I have 3 kids, and I love hiking, and then a month later I ask you, hey, what should I do in Hawaii on my vacation? I want to have that personalization from a chat AI assistant. But personalization, let me tell you, is a really tricky bit. Because when you implement it, and we actually looked at, again, competitors who also launched these personalization features, and then we see no difference. There's no actual difference in the answers. We're like, well, that's upsetting. So we shipped this in a small A/B test, which I encourage everyone also to do for these LLM models, of course. And in the A/B test, sometimes the model would over-personalize. You just ask, like, who's the president of France? And it'll start talking about hiking. And you're like, that's really bad too, right? So you have to have a whole system and different AI subsystem inside an LLM orchestration kind of layer and product that works at scale millions of times a day for users that says, like, is this query even a query that I should personalize? And oftentimes for search use cases, it isn't. But from time to time, people ask about things to do on their vacation. And so faithfulness to the prompt is another important criteria. So this is the set of results here in detail. You can look these up on blog.u.com too. But basically here we compare to Perplexity and ChatGPT. And somewhat surprisingly, especially with ChatGPT, we're just way more accurate. They're just, when you let the AI program, in general, Python, which, by the way, is also a huge security nightmare, because as soon as you launch that feature, people will ask the LM, oh, mine me some Bitcoins, and boom, the machine's gone, right, forever. Or like, hack this computer, go up 3 folders, tell me all the passwords. So it's a huge security nightmare. I don't want to egg anyone on here, but so far so good. We haven't gotten hacked yet. My security engineer is kind of scared about this feature and was trying to not have us ship it, but I do still think it is really, really cool when it just generates plots for you and so on. I'll show some examples in a minute. But biggest difference is basically for ChatGPT-4 that we have almost like over twice the accuracy. We are behind in conciseness to ChatGPT-4, which again is kind of a tough one in relationship to comprehensiveness. And then we have a slight advantage overall in the user preference with GPT-4. And then, yeah, for Perplexity Pro, it's actually much better on almost everything except clarity. So the formatting especially was something that we learned matters a lot. Like you want to have nice bolded paragraphs and sections and so on. And again, some people might be skeptical. It's like, well, ChatGPT, they're so amazing. So here's one example that we just actually took screenshots of the main premium ChatGPT-4 offering. And the question here is plot the graph of NVIDIA revenue for the last 5 years. And Genius Mode will go on the web, find facts, and then incorporate those, write Python code for you, and then run that code, and then give you this plot. And this is basically the result that we got, which is correct. I actually had a meeting with Jensen a couple of weeks ago, and he's like, yeah, could have been that ChatGPT was wrong, those numbers, but they were even better, and this is the actual, the true results. So it's kind of interesting and unfortunate that even ChatGPT-4 will kind of sound like this looks very reasonable, right? It's like it's very easy to think, okay, I'll just copy and paste that thing into my PowerPoint slides and then give the talk, right? But it's, again, these are not the actual accurate numbers. I'm gonna not go too much into details, but basically you can also look at the free modes, because the pro modes are paid and they cost money for us and the user. So you can look at also just the free offerings in there. What's actually kind of interesting and hopefully shows that this isn't like just some BS marketing study where we want to come out on top, but we actually are behind GPT 3.5 on several metrics: conciseness, faithfulness, and comprehensiveness, and are only ahead in clarity and accuracy. But I guess the accuracy does matter to enough people that we just inched out, even in the free mode, to be slightly ahead of GPT 3.5. But there's certainly more room for improvements when it comes to the free offering compared to GPT 3.5. And yeah, with that, this is not a number I've ever shared before, but one thing we've noticed is it just takes a lot of time. You have to keep shipping features. You have to keep studying and analyzing and carefully benchmarking every aspect of an LLM. And then as you do that more and more, your retention numbers will go up. Your churn keeps going down. And now we finally have retention in the mid-90s, even better than this now. And that, I think, is just nice to see. It's nice that once people actually pay for your product, they stay with your product because you keep doing that work on accuracy. And maybe I'll just add one more thing here, which is there are two stacks for an accurate LLM RAG system. It's, of course, the whole LLM orchestration layer, personalization, and so on, but it's also the search backend. And we actually built this new kind of index that essentially, you can think of it as similar to Google or Bing APIs, where you get a list of links, but instead of a very short snippet, you get many very long snippets. And that wouldn't be useful for people. Mostly these APIs are built for people to be able to choose which link to click on, but you can actually give all of that text to an LM that will then, in a few milliseconds, kind of read it all and then give you a more accurate answer. And so we, again, put our science benchmark hats on and actually compared this. And I thought even the evaluation here was actually kind of clever. It wasn't my idea, it's one of our engineers. But the idea here is you take a Q&A data set. So there's the Stanford question answering data set Squad or Microsoft Marco and so on. And the way traditionally these data sets have been used for evaluation was to have a paragraph of some text, and then you have a question, and then they would say, all right, this is the exact phrase in that paragraph that answers that question. And what we did is we basically said, well, let's just drop the whole paragraph, ask the question, and then use these different search APIs to find facts on the internet, and then see if the actual extracted paragraph or phrase from that is the correct one based on that official data set. And again, somewhat to our surprise, right? If you're a small startup and you say, oh, we beat Google on search, people are like, that's BS. So there's no way you do. But not by much, but it is actually better. And it's kind of because we're cheating, right? We're building a new index that is for LLMs. So just by giving the output, output that is much longer, has longer and more snippets, you just can essentially cheat to some degree by having that use case in mind, and can actually outperform Google and Bing. And we're now basically offering all of these capabilities, not just to end users on u.com, but also as APIs. I'm super excited to chat with everyone here, see if we can work together. We have a bunch of different, both general chatbots, but also internal companies and biotech companies and so on that are now incorporating this. Even the 1DB bot is using these APIs. I was just chatting with Lucas before. And yeah, we're super excited to work with you all. Let me know. I'll be here after, but there's no time for questions, unfortunately. But well, there's time, but no mics, so I'll be outside if you want to chat. All right, thanks a bunch.